Hello everyone, my name is Lipei Xiao. In this demo, I will explain the first part of our project, which includes the data overview, pre-processing, and exploratory data analysis. Our project uses accidental drug-related disease data, and our aim is to prepare the data properly before applying the data mining techniques. Here we have our business fields. We separated the project into data understanding, pre-processing, EDA classification, and classification real meaning. This makes the workflow clearly and easier to explain. The data set is called accidental drug related disease. It contains 11,181 records and 48 columns. Each row represents one test case, including information like age, gender, race, and the types of drugs involved. However, not all columns are useful for our analysis. Some are location-based or descriptive, so we only selected the relevant features for our project. Now, I will continue with the pre-processing code. This part is important because raw datasets usually contain unnecessary columns, missing values, and key data that machine learning algorithms cannot use directly. In the first line, we import pandas. We use pandas because it helps us load the CSV field and manage the dataset in table form. This line reads the dataset from the CSV field into a data frame called df. This is our starting point. These lines print the original shape and the column names. We include this because we want to confirm how many rows and columns the dataset has before cleaning it. In this section, we chose only the columns that are relevant to our analysis. We kept age, sexy, race, and the main drug-related indicators such as heroin, cocaine, methadone, and any opiate. We removed many other columns because they were location-based or descriptive, and they were not useful for our predictive models. Next, we check for missing values. This step is necessary because some machine learning models, especially KNN, cannot handle missing values directly. In our data, we found a small missing value in the sexy column, so we fixed it before model training. Here we covered the categorical values into numbers. This is needed because machine learning algorithms work with input. For the drug columns, we use binary encoding, where 1 means the drug is present and 0 means it is absent. This makes the dataset much easier to use for mini patterns and predictions. Finally, we save the cleaned data into a new field called cleaned drug disease CSV. This allows the next scripts to use the prepared dataset directly. Now I will run the pre-processing script. We can see the output confirming the selected columns and that the cleaned dataset has been saved successfully. Uh, After pre-processing, the next step is exploratory data analysis or EDA. This helps us understand the distribution and the patterns in the data before building the models. In this field, we first load the cleaned dataset, then we generate several graphics to observe the structure of the data. This first graph is the age distribution. We use a histogram because it shows how the cases are spread across different ages. Uh, this section creates the gender distribution chart. It helps us compare the number of male and female cases. This part sums up the binary drug columns and show which drugs appear most frequently in the dataset. This is useful because it gives us an early idea of which substances are most common. This final visualization is a correlation heat map. It shows whether some variables tend to appear together more often. Now I will run the EDA code. Okay. From the age distribution, we can see that most cases are concentrated roughly between 13 and 16 years old. From the gender chart, males are more represented than females. From the drug frequency chart, fentanyl appears as the most common substance. The heat map also suggests some positive relationships between synthetic substances. After seeing the graph, there are also some basic summaries of the result. That's the end of my part. Next, my teammate will explain the classification models and how we evaluate them. Okay, next one.
Well, okay, okay. Hello everyone, my name is Liu Yichen. I will explain the classification part of the project. Our classification take is to predict whether this case involved opioid. For that, we use any opioid column as the target variable. In this view, we start by importing the necessary libraries from scikit-learn. We use scikit-learn because it provides ready-to-use machine learning models and evaluation tools. Here, we load the cleaned dataset that was prepared in the previous step. We check again for missing values before training. This is a safety step. Even after pricing, we want to make sure there are no remaining new values that could case the models to fail. In this section, we split the dataset into features and target. X contains all the input variables, where Y contains only the target column, which is any opioid. We use an importer to fill any remaining missing values using the most frequent value. This is important because some models, especially KN, can cannot update the missing data. This lens splits the dataset into training and testing data using an 80-20 ratio. This is necessary because we want to train the models on one part of the data and evaluate them on unseen data. That give us a fair measure of performance. Next, we standardize the data for KNN and logistic regression. Scaling is needed because these algorithms are affected by difference in variable ranges. Decision tree doesn't require screening, so we keep its input as greater. This section creates and trains the decision tree model. After training, it predicts the levels for the testing data and calculates the accuracy. This section does the same for KNN. We set a neighborhood equals 5, which means the model classifies case based on the 5 nearest points in the training data. Here we train the logistic regression model. Since our target in linear logistic regression is a very stable model for this problem. In the last part, we compare the accuracy values of the three models and identify the best one ultimately. We also point the classification report for the best model. Okay, now I will run the classification script. Okay. Before I discuss the result of the code, we can see that above the result is the before and after the a check for missing value. This shows that with the importer or missing value is filled in. Okay, now onto the result part. Our results show that the decision tree achieved about 76.5% accuracy. KN achieved about 78.6%, and the logistic regression achieved about 79.6%. This means logistic regression performed the best among the three models. The confusion matrix shows how many keys were correctly and incorrectly classified. In our best model, the algorithm identified opioid related keys more strongly than no opioid keys. Looking at the precision, Recall and F1 score, the opioid class performs better. With an F1 cross around 0.86, this suggests the model is relatively reliable in identifying opioid-related deaths. The result makes sense because the selected drug related features are directly connected to opioid environment. So logistic regression can learn a clear relationship from the data. Okay, I will now pass to my teammate who will explain the execution rule meaning part and the final conclusions.
Okay, hi Miss. My name is Liu Yusen, and I will explain the last part of our project, which is a station, the role means, and the final conclusion. This film is used to find a drug combination that are often play together, and unlike the classification, this part does not produce anything. It only finds the pattern and the relationship in the data. And the important print and association run rules from the mix Franklin's partners. And these are the main tools we used for the extension rule grooming. And here is we load the clean data again. In this part, we only keep the drug functions with 0 and 1 visual, and this is because the R station roaming works better with the trip of the data, and where will show yes or no. And this line run the approach, the we set a meaningful supposed will so that we only keep the combination and appear often. This helps us to remove the weak and refine the patterns. After getting the frequency items, we create the rules use the confidence, and then we keep the important terms like the extensions, contributions, post, and left. Supposed to mean how often companies in the data confidence mean how like the results happening when the confidence happen. As the show is if the relationship is strong, then recall the return rules. If the letter is more than one, it means there is a strong nation. Now I will to run the rules code. Okay, for the results, we can see that any options and functions I have very high exposed. This means that this approach is in many cases. One strong rule is the consequence friendly. Any option with the above 0.92. This means when the constants and the functions approve together, it's very likely to approve. Any important rule is functions any with the confidence close to 0.90. This shows the strong correlation with between the frequency and the open rule data. This result show the film is very important in this data. This also shows that many cases include more than one drug. This means overdose are often cases by drug combination and not just the drug. For the conclusion, we did the data clean EDA and classification, evaluation, and algorithm rounding. We found the frequency is one of the most common drugs. Velocity is the best model among the three. We also find a strong combination between the drug, expanding function, and the kinase. Work for this work, we tested is into the three parts. This is the first member, did the data understanding, cleaning, and the EDA. The second member did the classification and the evolution. The third member did the running, the results, expanding, and the final report. Okay, thank you for your watching our demo.